Last time, since we've seen the different types of partial fractions, this time we're going to see how to solve a partial fraction specifically. So we've seen two different functions, right? We're going to solve both of them. So the first one, integration px plus q by x minus a, x minus b is equal to a by x minus a plus b by x minus b. This was type 1, right? So we're just going to solve this, and type 1 and type 2 follow the same procedure, so it's going to be easy. So what you're going to do here is, first you're going to cross multiply these and get a x minus b plus b x minus a. Because you cross multiplied, you added both of them, and you're going to get the denominator as this x minus a dot x minus b, right? But instead of the denominator here, we're going to cancel it with this denominator. Okay, this is also integration dx, but we're going to ignore it for a while and we're going to come back to that. So you're going to get px plus q by denominator, which is this, is going to be the same as this, right? This. So you're going to cancel this and this, which is basically both the denominators. What you're going to be left with is px plus q is equal to a x minus b plus b x minus a, right? So from this, what you're going there's two things you can do. First, you can compare the x terms or the constant terms, or x squared, x cubed. If it exists, you can compare those terms. And what I mean by that is, suppose you have x square plus 2 is equal to uh, a actually no, never mind. This is harder. What I'm trying to say is, when you're to multiply the x terms, you get x plus 2. Suppose let's just assume, or 4x plus 2 to make it easy, is equal to, we're going to take, when we're multiplying this, we see ax is there, so we can see that the coefficient of x over here is a, so you can put a over here since that's one of the coefficients, and then plus, because we see bx over here, right? So since the coefficient of x is b over here, we can just put b here. Now that is one equation that we find, or wait, I made a mistake again. Since from that left hand side, let's forget that equation first. From that left hand side, since the coefficient of x was 4, you take 4. So 4 is equal to ax plus b in the example. So you're going to get one equation like that, and you can compare x terms, x square terms, constant terms, and you'll get different equations. That's one way to do it. And the other thing that you have to do is substitute values for x everywhere. Okay, so how you're going to substitute is, it depends on b and a, right? So if b is suppose 1, you're going to get -1 here. You're going to put +1 here to make this 0, and then a cancels out, and here you're going to get some value, and here you're going to get -1, +1 +1. You're going to get b 2b, something like that. 2b is equal to, and then some constant over here, and then you'll get the value of b. And then you can do the same, you can substitute another value of x, and then you'll get the value of a. And if there's more terms, you can you'll get different equations for these and these, right? You have to solve those equations, and then you'll get a and b, right? Why did I raise that? But you'll get a and b. And what you do with this a and b is, you put it back in this equation, and you solve it like a regular integration question. You get a by x minus a plus b by x minus b dx dx. You solve it like a regular integration question, since you already know the values for a and b, and they're going to be constants. They're always constants. And since you know the regular integration formula, you're going to send the constant out, and you'll get 1 by x minus a. something and you can use the formulas to complete the integration. So basically that's how you do it. This is for type 1 of this kind of function. Now for type 2, you're going to be having an equation like px square plus qx plus r, right, by let's take the hard one, x minus a, and x square plus bx plus c. So since we studied in the last video, this part you can you can factorize it further. So what you're going to do is the formula, as I said before, x minus a by x minus a, because that's the normal part, and then plus bx plus c by x square plus bx plus c. Now since that's used, you're going to do the normal method, as in you're going to send this, cross multiply, cancel out the denominators, and then the usual, you're going to compare the x terms, you're going to compare x square terms, you're going to compare the constant terms. Before that, you can substitute x values for the entire equation, and you'll get a, b, c values, and with that you can find you can integrate this equation, right? You're going to get, since this is all integration anyway, dx, you're going to get a by x minus a dx plus integration bx plus c by x square plus bx b, as in small b, I'm sorry, plus c dx. And x plus 2 value, you're going to the the split it into two terms, and then you're going to do it like normal integration. So yeah, that's the second type. Now this is actually very simple. I was first not going to do this, but then since people might still be confused, I'll do this very quickly. So from this, you're going to get a by x minus a plus b by capital B, capital B, x minus b plus c by x minus a. So with this, you're going to get integration dx, and you're going to use the usual. You're going to, let me write that down for once. Substitute values for x, or slash, and you're going to compare x terms. And when I say x terms, they can also be x square, x, or x cube, da, 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 and then constant terms. And from this, you're going to get a plus b. You're going to get a b c. Sorry, you're going to get a b c, and from this a b c, you're going to just integrate it as normal, and you're going to split it separately, integrate it normally, and that's partial fractions in general.